Welcome to the deep dive. Today we're looking at a truly groundbreaking development coming out of Google DeepMind, this AI agent they're calling AlphaEvolve.
hmm
Our source material today is a really fascinating article from Wired, published just, well, very recently, May 14th, 2025. And what makes AlphaEvolve so significant, really, is its ability to create algorithms that aren't just, good, they actually surpass human expertise.
That's exactly right. And this isn't just AI, like automating things we already do. The Wired piece really gets into how AlphaEvolve is designing completely new ways to solve problems, new algorithms that are proving, well, more efficient than what humans have come up with.
So our mission for this deep dive is to really unpack that. How does AlphaEvolve actually do this? What's being used for right now? And, what are the bigger picture implications for AI, sure, but also for human ingenuity itself?
Yeah, it definitely sparks that question.
Right. Can AI really be creative, come up with something totally new? Or is it deep down just incredibly sophisticated pattern matching? Let's dive in. All right, so first things first. How does AlphaEvolve actually, pull off this algorithmic magic? What's the core mechanism here?
Well, the article breaks it down into sort of three key parts. First, it uses the coding abilities of Google's Gemini AI model.
Okay.
So you can think of Gemini as giving AlphaEvolve this really deep understanding of code, how to write it, how it works, the fundamentals.
Okay, so Gemini handles the basic coding smarts. What's piece number two?
The second really crucial bit is an evolutionary method. Basically, it generates lots and lots of new algorithm designs.
Evolutionary, like survival of the fittest for code.
Exactly. Kind of like that. Imagine trying out hundreds, maybe thousands of slightly different versions of a program. You test them, see which ones work best.
Right.
The winners then get to, well, reproduce. Their best bits are combined, maybe tweaked, a little mutated. And that creates a whole new generation of potentially even better programs. That's the core idea, this evolutionary cycle happening digitally.
That's a great way to put it. Digital trial and error, constantly refining. Okay, and the third part. What makes the whole thing hang together?
The third piece is having a really rigorous way to test how effective these new algorithms actually are.
The testing.
Yeah, this lets the system objectively measure performance, figure out which designs are genuinely better, and that guides the whole evolutionary process towards, more and more efficient solutions. It's not just throwing code out there randomly. It's systematic improvement.
And the headline news, the really big takeaway here is that this combination, Gemini's coding, the evolutionary process, and that strict testing, it's actually resulted in AlphaEvolve designing algorithms that outperform the ones we humans created. That's quite something, isn't it?
Oh, absolutely. The article really emphasizes that. AlphaEvolve has successfully designed algorithms that are demonstrably more efficient, provably better than human-designed ones for several, specific, but very important computing tasks.
Can you give us an example, something concrete that shows just how big a deal this is?
Sure. One example that really stands out is how AlphaEvolve improved the Strassen algorithm.
Strassen algorithm. Okay, remind me.
Right. So this algorithm, Strassen's, it's been sort of a fundamental recipe for doing matrix calculations, basically.
Yeah.
A specific kind of heavy number crunching that happens all the time in computers. And it's been the go-to method for, wait for it, 56 years.
56 years. Wow.
Yeah. And AlphaEvolve found a way to reduce the number of steps needed for these calculations, making the whole process faster, more efficient, improving on something that fundamental, that long-standing. That's pretty remarkable.
It really is. A decades-old standard, improved by AI. So, okay, where are these improved algorithms actually being put to work? Like, in the real world?
Good question. The article points to three specific areas where DeepMind is already using AlphaEvolve's creations. First, optimizing how tasks are scheduled inside data centers.
Ah, okay. That makes sense. Efficiency there is huge.
Exactly. Think about the scale, the energy these places use. Even tiny improvements in scheduling efficiency can mean big savings, better performance overall.
Right, huge impact. Okay, what else? What are the other areas?
Second, they're using it to help sketch out the designs for computer chips.
Chip design. That sounds incredibly complex.
It is. It's super intricate, takes a ton of time. So any AI help that can streamline that process, make it faster or find better designs, could really accelerate hardware development.
So it's helping optimize the software side in data centers and now also the physical hardware design with chips. That's
Yeah.
quite a range. What's the third application?
The third one is maybe the most interesting in a way. It's optimizing the algorithms used to actually build large language models, like Gemini itself.
Wait, so it's AI helping to build better AI?
Kind of, yeah.
Yeah.
It's like this self-improvement loop,
Yeah.
using AlphaEvolve to make the process of creating future AI models more efficient.
That is fascinating. The article quotes Pushmeet Kohli, who's head of AI for science at DeepMind. He really stresses how critical these three areas are: data centers, chip design, LLM building, and the whole modern AI world. And he says AlphaEvolve could go much beyond what is known in terms of solutions. That really does underline the potential, doesn't it?
It really does.
Okay, but this brings us back to that question about, novelty. Is AlphaEvolve really creating something brand new? Or is it just super good at finding clever combinations of things humans already figured out?
That's a crucial distinction, and the article gets into it using insights from Matej Bolog, one of the lead researchers.
Yeah.
She argues pretty strongly that, yes, with AlphaEvolve, they can actually show genuine novelty, which is often really hard to prove with code.
How can they be so sure? What's the proof?
Well, Bolog explains they have methods to, quote, show very precisely that you can discover something that's provably new and provably correct. He even says they can be really certain that what you have found couldn't have been in the training data.
Couldn't have been in the training data. That's a strong claim.
It is. And it suggests that this evolutionary process isn't just remixing old ideas. It's genuinely generating algorithmic designs that are fundamentally new.
Okay, interesting. Now, the article also includes perspective from an outside expert, Sanjeev Arora from Princeton. What's his take on all this? Does he see it as equally revolutionary?
Aurora offers a bit more of a nuanced view. He sees the specific advancements AlphaEvolve has made so far as, quote, relatively small in the grand scheme of algorithm design.
Relatively small, okay.
Yeah, he points out that they seem particularly good for algorithms where the main task is searching through a defined set of possible answers to find the best one.
So, like, finding the optimal path or solution within known boundaries?
Sort of, yeah. But importantly, Aurora adds a counterpoint. He says, search is a pretty general idea applicable to many settings.
Ah,
So while the current specific examples might seem focused, the underlying capability AI discovering better algorithms through search could actually apply much more broadly down the line.
it's interesting to place AlphaEvolve in that bigger picture of AI's growing role in software development. It feels like we're moving past AI just being a tool for simple automation, doesn't it?
Definitely. The article notes how current AI, the code assistants and things, are already making it easier for people without deep coding skills to build simple apps or websites.
Right, lowering the barrier to entry. But it's not just for beginners, is it? Experienced developers are using AI too.
Oh, for sure. They're using it to handle the more routine stuff, automate parts of their workflow, which frees them up to focus on the harder, more creative problems.
Yeah.
AlphaEvolve seems like the next step, potentially moving beyond just writing code efficiently to actually contributing to the fundamental design of that code should work.
There's another researcher mentioned, Josh Allman from Columbia University. He works on algorithm design too. What did he find exciting?
Allman really emphasizes that AlphaEvolve seems to be generating novel ideas, not just remixing its training data. He basically says for it to make these specific improvements, especially on things like the Strawson algorithm, it has to be doing something new.
Doing something new. And he also talked about collaboration, right? Humans and AI working together.
Yes, that was a really interesting point he made. Allman envisions a future where scientists could basically collaborate with systems like AlphaEvolve. You could give it high-level goals, maybe outline a complex problem.
And then the AI could explore different algorithmic approaches.
Exactly. It could generate potential new strategies, new ways to tackle the problem that a human might not have thought of. He found that potential for human-AI co-discovery really exciting.
And this isn't DeepMind's first rodeo with AI showing surprising ingenuity, is it? They've had other projects hit the headlines.
That's right. The article gives a quick nod to a few others. AlphaZero, for instance, that was the AI that taught itself games like Go and chess.
Right, and came up with totally original strategies.
Yeah, just through playing against itself, through experimentation. Then there was AlphaTensor in 2022.
AlphaTensor, what was its focus?
That one used reinforcement learning, a different AI technique, also to find new, more efficient algorithms for matrix multiplication. So related to AlphaEvolve, but a different approach.
And FunSearch, that was more recent, 2024.
Exactly. FunSearch used an evolutionary method, much more like AlphaEvolve's, to generate efficient code for solving certain math problems. And interestingly, Matej Bolog, the researcher we mentioned earlier, even suggests maybe combining these approaches in the future.
Combining the evolutionary method with reinforcement learning.
Yeah, potentially using both to explore new ideas across an even wider range of scientific fields.
So thinking longer term now, what are the really big implications if AI like this can consistently innovate in algorithm design for science, technology, everything?
Neil Thompson, an MIT scientist who studies the economics of algorithms, brings up that exact point. He asks the crucial question, how broadly can these capabilities apply? Can they go beyond these specific computer science examples to tackle the bigger, messier, less defined problems we face in scientific research?
Right. It works for optimizing matrix math, but can it help cure diseases or design new materials?
Precisely. And Thompson's view. If these AI capabilities can be generalized to those bigger scientific challenges, the potential is enormous. He says it could significantly accelerate innovation and thus prosperity. That's the big prize, really.
So, okay, let's try and wrap this up. The key takeaway seems to be that AlphaEvolve represents a really significant step. AI isn't just processing information anymore, it's starting to generate genuinely novel solutions in really complex fields, like designing the algorithms that run everything.
Exactly. We've talked about how it's already improved fundamental decades-old algorithms like Strasson's, how it's finding better ways to run data centers, help design chips, even optimize the AI models themselves. It's pretty impactful already.
It really is. So this deep dive leaves us, and you, with a final thought to chew on. If AlphaEvolve can already surpass human experts in these specific critical algorithmic tasks, what other areas of human skill, human knowledge might be next? Where else could AI make these kinds of breakthroughs? And maybe more profoundly, how might that change how we think about our own intelligence, our own creativity in the future? Definitely a lot to think about there. Thanks for joining us for this deep dive.